This lesson is about hyperbolas. A hyperbola is the set of all points P in a plane such that the absolute value of the difference of the distances between P and two fixed points is constant. And it's probably best to see this through an applet, so let's pull that up and take a look. Okay, so I have two focal points labeled F1 and F2. And I have a point A, which is defining a vertex. And then the point in the middle is the center of my hyperbola, and point P is going to be a point on the hyperbola. And those dashed lines that you see represent the distance of point P to the focal points. And what we want is the absolute value of those to stay constant. So what you're seeing in this equation down here that I'm moving is if I take 1.8 minus 7.8 and take the absolute value, I get 6. Now if you'll notice that if I move the location of P, well, if I can grab P, there we go, then the distances change, but the absolute value of the distances stays constant. The absolute value of the difference of the distances, that is. And what is interesting is there's actually two parts to a hyperbola where this works out. So you actually get two sets of points like this. It kind of looks like two parabolas that are facing in opposite directions of one another. And you can orient the hyperbola, differently. If you bring A closer, the hyperbola is wider. Okay, you get mirror images on both sides. There's a lot of symmetry with hyperbolas. If you could have a hyperbola that opens up and down. That's perfectly permissible. Let me change some things and we'll see what that looks like. So it would just look, along these lines. Okay, so that's what hyperbolas can look like. So let's start defining the different important aspects of a hyperbola. So we have the two fixed points that we are interested in, and each of those fixed points is called a focus. So I'm just going to put my foci here and here. I can call it F1 and F2. The places where the hyperbola crosses the x or y axis. These are called the vertices. So these are the vertices in this case. I'll call this V1 and V2 perhaps. The line that passes through the foci is called the transverse axis. So I will do a dashed line here and call this the transverse axis. And then the line that's perpendicular to the transverse axis is called the conjugate axis. And the conjugate axis passes through the center of the hyperbola and the center of the hyperbola is located at the midpoint of the foci or the midpoint of the vertices as well. It is not an actual point on the hyperbola. So my center point, in this case, is this point right here. That's my center. When I'm using the equation of a hyperbola, generally the center is easy to locate, and then I have to calculate where the vertices and the foci are. Lastly, the hyperbola contains two asymptotes that pass through the center and direct the hyperbola as it approaches infinity. And those lines are going to be a little bit difficult to draw, but I'll do my best here. But they are two lines that guide the direction of the parabola, of the hyperbola as it goes to infinity, but passing through the center. So these would look something like that. And those are the two asymptotes of the hyperbola. When we consider formulas for the hyperbolas, then what we need to do is determine first if it's a hyperbola that's opening left or right, or a hyperbola that's opening up or down. So let's first talk about left and right. So if it's opening left and right, this is what the hyperbola would basically look like. And this is the formula. So notice in a left and right opening hyperbola, the very first variable that shows up is the x variable. So x is first. That's going to make it open left and right. Now, the a squared and the b squareds are a whole lot less confusing with hyperbolas than they were with ellipses. A squared is always the number under the first variable, b squared is always the number under the second variable. And a determines the distance that you move along the transverse axis, b is the distance you move along the conjugate axis. Notice the only difference between this and an ellipse is that we subtract the two. And what's nice about that is when we get the location of the foci, we just use the regular old Pythagorean theorem here. So you only have to remember that in ellipses you have to use a special formula to calculate those. So what ends up happening is the distance from the center to the vertex along the transverse axis is a distance of a. And then there's from the center up and down is a distance of b. So I'll put, this is a distance of b, this is also distance a. And if you make a box around your values a and b like this, then what you get is the corners of this box dictate which direction your asymptotes are going to go, which is very helpful. So A is the location of your vertex, B is just this helpful point for the box, C is the location of your focal points. So if you take, in this case, you originally would start at H and K, but we're moving in the x direction, so we would do like x, H plus or minus C, comma K. So this one, actually, let me write it this way. So this point would be H plus C, comma K, and this focal point would be H minus C, comma K. All right, so you can find your focal points that way. In this case, the transverse axis is horizontal. The foci is always C units from the center. The vertices are always A units from the center. And the asymptotes you can remember as a formula, but I tend to prefer the box myself. And if the parabola, I'm sorry, I just keep saying parabola. If the hyperbola opens up or down, it would look this way. And the formula would look like this. So notice here, y is first. That means your parabola is going to open up or down. The way you calculate c squared, which is the distance to your focal points, the same. Transverse axis would just be vertical. Your foci is still C units from the center. Your vertices are still A units from the center. Your asymptotes change, but again, if you're using the box instead of anything else, instead of memorizing formulas like this, you don't need them. So, the first example. Identify the location of the center, vertices, and foci, then provide a sketch of the hyperbola and identify its domain and range. Okay, so there's no best place to begin, just kind of get started with it. One thing I notice is the y is the first variable, which means this hyperbola is going to open up or down. So that's a good place to begin. The center is always easy to identify from the formula. In this case, it's going to be 2, -5. We just take the coordinates h and k. Although I do have those reversed. Look at that. Not so simple, apparently. So it would be -5, 2. All right, so my center is at -5, 2. So -5, 2. Just put that as a center point. Okay, it is opening up or down, though. Other things that I could derive, the value underneath the first fraction here is always a squared. This one's always b squared. And in order to find my vertices, I could use a. So the vertices, I know it's opening up or down, so my transverse axis is going this way. So that means my vertices would be up or down by 4 units, because if a squared is 16, that means a is 4. And to go up or down, I change the y variable, so 2 plus or minus 4. So I get the coordinates -5, 6, and -5, 2 minus 4 is -2. So -5 and 6, there's a vertex. -5 and -2, there's another vertex. I generally don't draw the transverse axis because it just gets too many things on the chart, but it's fine for now. Foci. In order to get the foci, I'm going to need to solve for the value of c. Now, c squared is just a squared plus b squared, which in this case I know is 16 plus 9, which is 25, so that means c is equal to 5. The foci are also located along the transverse axis, so those coordinates then, I would start from the center and move my y variable plus or minus whatever c is. So it's going to be -5, 7, and -5, -3. So this is a focal point here, and this is a focal point here. Okay, now the only thing that I haven't used is b. So let's see what I can do about that. So b is going to be the distance that I travel along the conjugate axis. Since b squared is 9, that tells me that b is 3. So if I go 3 units from the center left and right, 1, 2, 3, 1, 2, 3. This creates that box that I was referring to. Draw it in here real quick. So it's a distance a from the center up and down in this case, b from the center left and right. Now, because I can't draw straight lines very well, I'm going to just do this real quick here and try and get through the points as best I can. So right through the center and the corners of the box. That's pretty good. And I'm not going to be quite so good this time. I wonder if I can move it so it's a little bit better. That'll do. Okay, now that gives me my asymptotes, which guides my hyperbola as I go to infinity. So my hyperbola, I'll do in green just because blue's all over the place here. So I just draw my hyperbola approaching that set of asymptotes as I go to infinity. And there's a pretty good sketch. Now, in terms of domain and range, I think that's the last thing that's asked here. So the domain and range, I'll just get from the picture itself. So the domain, if you can imagine smashing that hyperbola up against the x-axis, you're going to see a green line everywhere on that axis. So the domain is from negative infinity to positive infinity. Then if you do the same thing but smash everything up against the y-axis, then you won't see a green line everywhere, but you will see one from negative infinity up to -2, and then again from 6 up to positive infinity. So that's the domain and range of my hyperbola. Identify the location of the center, vertices, and foci, then provide a sketch of the hyperbola and identify its domain and range. Okay, so this time x is first, so that means my hyperbola is going to open left or right, or actually left and right. It opens both ways. The center is relatively easy to identify. In this case, it would be 4, -3. So 4, -3 would be right here. Now, a squared is 16, so that we know a is 4. B squared is 9, so b is 3. So remember, a is always going to happen first in the set of fractions, b is always going to happen second. They don't swap places like with the ellipses. Okay, then the next thing that I want are my vertices. So this thing's opening left or right, so that means my transverse axis is horizontal. Now this time I'm not going to draw the transverse axis because, as I mentioned, it just kind of gets too many things on the graph. So, but I do know that I'm going to move in the x direction by 4 units left and right. So the center starts at 4, -3, but I'm going to move left and right by the value of a. So that puts my vertices at 8, -3, and 0, -3. So let's draw those in. So 8, -3, there's a vertex, and 0, -3, there's another vertex. Okay, the location of the foci I would have to get by using this function right here in order to define what the distance of the foci is. So c squared is a squared plus b squared. A and b, well, a squared is 16, b squared is 9, so it's 25. So c is 5 again. And since c is 5, we can locate the foci. I've got to move in the x direction, so I'm starting at 4, -3, which is where my center is. But I'm going to move in the x direction by 5 units. So my two foci are at 9, -3, and -1, -3. So there's one of my foci, and there's the other. Okay, now I'm going to draw this box that's going to help me get the asymptotes, and then once I have the asymptotes, I'll draw the actual hyperbola. So the value b is 3, so I would go up 3 from the center and down 3 from the center, and then draw this box. Okay, so let me draw in a line that will represent my asymptotes. I'll do my best to get it right through those corners and the center. It's not too bad, but I'll bring this side up a little bit. All right, and the other side. Oh, I missed that pretty badly. I can fix it though. That's good. Okay. All right, that's not bad. Now with that, I can actually draw a pretty decent sketch of my hyperbola. So just start with the vertex and kind of go toward the asymptotes, letting the asymptotes guide the hyperbola to infinity. And recall that I knew that this one is opening left and right, so that's why I'm drawing it left and right instead of up and down. Now for domain and range, the last bit. This time the domain has a restriction. So if I smashed everything up against the x-axis, the parts where I would see a green line would be from negative infinity on the x up to 0, and then from 8 on the x up to positive infinity. And then the range is unrestricted in this case, so from negative infinity to positive infinity. Next, we want to write the equation of a hyperbola with the following characteristics. So we have vertices at 2, 3, and 2, 5, and a focus at 2, 2. So it doesn't say to graph it, but generally you can organize your information a little bit easier and figure out what you want to do if you graph it first. So vertices at 2, 3, and 2, 5. And we have a focus at 2, 2. So, I'm not going to be drawing this perfectly, but I know based off of where these vertices lie that this hyperbola is going to open, up and down, which gives me a very good hint as to the formula that I'm going to use. I need the y variable coming first in order to make it go up and down. So then I just need to figure out what a squared, b squared, and the center is. Now the center is going to be right in the middle of the vertices. So since these are 2 units away from each other, then that means my center is going to be at 2, 4. And you could calculate that by, if you took the average of 3 and 5, basically you're finding the midpoint there. All right, so that's needed. I also need A and B. A is going to be the distance from the center to the vertex. So A is equal to 1. So I have A equals 1. C is from the center to the focus, which is 2 units, as you can see from the drawing. So then we can calculate B, because c squared is a squared plus b squared. So 4 equals 1 plus b squared, or 3 equals b squared. So that means my equation is going to be y minus 4 quantity squared and x minus 2 quantity squared, and underneath the y is the value of a squared, which I know is 1. I could leave that off, it doesn't really matter. I tend to just put it in. B squared is 3. So now I have the equation of that hyperbola. Write the equation of a hyperbola with the following characteristics. Center at negative 3, 1. So negative 3, 1, there's a center point. Focus at negative 3, 5. And a vertex at negative 3, 4. Okay, so a couple things I can determine just right away. The distance from the center to the vertex gives me the value of A. and in that case it's 3 units. The distance from the center to the focal point is c, and right here it's going to be 4 units. So using that, I can calculate b. So because c squared is a squared plus b squared, so this would be 16 equals 9 plus b squared. If I subtract 9 over, 7 equals b squared, or b is the square root of 7. And this hyperbola would be opening up or down, so the y variable would need to come first. And so I can come up with my equation just by plugging in where the center is. So the center is at -3, 1, so y minus 1 quantity squared over something, and I'll fill it in a second, over x plus 3 quantity squared over something equals 1. And then a squared goes first, so a squared we know to be 9. And b squared we just calculated as 7. Write the equation of a hyperbola with the following characteristics: foci at 2, 7, and 8, 7, vertex at 3, 7. So 2, 7, and 8, 7. So focal points here and here. Vertex at 3, 7. Okay. Now, in a lot of these examples, the focus is ending up 1 unit in front of the vertex. It doesn't have to be that way. It just happens to be working out in a lot of these examples, but it can be any distance. Well, it would have to be greater than 0. All right, the center is a point that we're interested in because we need the location of the center for the basic equation of our hyperbola. And you could find that by taking the midpoint of the foci, but I can see here pretty easily it's at 5, 7. All right, so this hyperbola would open left and right because the vertex, it's going to open toward the foci. So based off of where my vertex is and the foci are, it's going to open left and right, which means I would need the x variable to come first. Now, the things that I have so far, I have the value of a, because a is the distance between the vertex and the center, and it looks like that's going to be 2 units. Then I also know the value of c, because c is the distance from the center to the focal points, and in this case c is going to be 3. I don't know why I wrote a. So c equals 3. So we can calculate b. So c squared is a squared plus b squared. 9 equals 4 plus b squared. So b squared is 5. And my equation then, since I know the center point, it's going to be x minus 5 quantity squared minus y minus 7 quantity squared over something equals 1. So a squared goes under the x variable, so that's 4. B squared goes under the y, which is 5.